Hey guys, in this example we are going to show you how we use our theoretical knowledge of differential equations to solve real life problems. So as you can see, we are standing on the 5th floor, which is 40 meters high, and we're dropping a ball and we're going to measure if our S actual is equal to our S theoretical. So this is the video, and it takes the ball 1.81 seconds to hit the ground. Let's start with our first equation. So in this, G is equal to my gravitational acceleration, my M is equal to the mass of the ball, which is a basketball, K is a constant of proportionality, V is the velocity after t seconds. Okay, so there are two forces acting on the ball while it is in free fall: a downward force caused by gravity and an upward force caused by drag. These are the two equations you can find. So in this equation, A is the rate at which V is increasing with respect to time. We can therefore write it as A is equal to dV over dt. So we sub this into equation number 1, where M dV dt plus kV is equal to mg. We're going to divide by m throughout. And we end up with this equation. Now we get the integrating factor, which is E, the integral of k over m dt. And if we integrate this, we end up with E k t over m. This is done by integration. We then divide by e to the power of k t divided by m by both sides. We are then left with V is equal to mg over k plus c times e to the power of negative kt divided by m. Okay, the ball was released from the building, so therefore the initial velocity is equal to 0. And because the building is obviously stationary, t is also equal to 0. So therefore we substitute these conditions in to get this. And we can therefore find out our C value. And we then substitute it into our previous equation. We then take mg over k out as a common factor. And we're left with this. This formula is used to calculate velocity in terms of t, the independent variable. The next step is to determine the formula for the distance the ball travels. This will be denoted by the letter S. Remember that t is the independent variable, so the formula for distance in terms of t is found like this. We then integrate. This is to find our distance. So let us now integrate with respect to t. And we are left with mg over k, open parentheses, t plus m over k e to the power of negative kt over m, close parentheses, plus k. Now substitute these two initial conditions into the equation, s equals 0 and t equals 0. Now we have to find a formula for acceleration in terms of t. So we say a is equal to dv over dt. So to get the value of a, we differentiate v, and we know that our v is equal to mg over k, open bracket, 1 minus e to the negative kt over m, close bracket. So dv over dt is equal to mg over k, open bracket, 0 plus k over m e to the negative kt divided by m, close bracket. So that is positive because negative k over mt times negative 1 is equal to a positive answer. Therefore, we get a to be this, when t is equal to 0. And we know that g is a gravitational force which is 9.81 meters per second. And now we insert our actual t value, which was 1.81 seconds. So we substitute what our a is equal to and our g into the above formula. And we left with 1 is equal to e to the minus k over m times 1.81. To get rid of e, we introduce ln on both sides. We then get the ratio of k over m on its own by dividing both sides by 1.81. We then inverse both sides to get the ratio of m over k. Now that we have a value for m over k, we can substitute it into the distance equation. Now we can substitute all our known values into the distance equation to solve for the only unknown, which is distance. If we substitute all our values in, we'll get an answer for s to be 13.3117 meters. Now our original measurement was 40 meters, but the difference between the two could be because of human error, maybe not having an accurate enough measuring tool to measure the height of the building, or the time taken when using a stopwatch wasn't 100% accurate. Even so, the answer is very close and thus proves the fact that we can use differential equation in real life application. Thank you guys for watching.